Okay, this is video 4 for chapter 12.2. This is from your handouts. The next one we're going to analyze the graph. So this is a little bit kind of weird because this is figure 8 and this is figure 7. And they say figure 8 represent the function. So this one is f of x. And figure 7 represent the derivative at line of x. Okay, so I want to make sure everybody note that part. And why the interval of the function is increasing and decreasing, local maximum, minimum, and concave up and concave down, find the inflection points. Compare that to the textbook analysis at the bottom. So I found the textbook analysis is a little bit confusing, so I do it like this. If we look at the functions, we can easily tell it's going down until here, right? So that's decreasing. So one of them talk about the function is increasing and decreasing. F of x is increasing, f of x is decreasing, right? So the decreasing part is starting from, and remember we're looking from left to right in terms of x. Okay, so starting from negative infinity is decreasing, go all the way down to x equal to 1. Okay, and starting from 1, it's going back up, right? So it's going to be 1 to positive infinity, okay? And the local maximum and minimum. So remember, maximum and minimum have to be down and up, right? For the local minimum. Do we have one? So down and down is not, down and up is. So this point is about x is 1, y is a little bit of negative 1 point something, okay? So the point is 1 and y is negative 1.4, something like that. Do we have a local maximum? Go up and down. So local maximum up and down, we don't have any, so it's going to be none. Are we okay? All right, concave up and down, yet we have to be extra careful, right? Concave up like a cup or smiley face, concave down like a frowny face. So that look like concave up this side, right? And that look like changing, and then starting here, it look like up again, right? So concave up is starting from negative infinity to, this is negative 2, x equal to negative 2. And also, this whole thing is like a smiley face shape, right? So it's going to be starting x equal to 0, y equal to infinity. All right, and this part is like change a little bit. It's the concave down, like a frowny face, just from this point to this point. We have from x is negative 2 to x equal to 0. So look at this again and see if that makes sense, okay? And for the inflection point, it's going to change from concave up to concave down or concave down to concave up, right? So the concavity change for inflection points. So look like here, we got one concave up to down. So this point is going to be x and y, x equal to negative 2, y equal to 2. And then again, down and up. So the second point would be 0, 0. So if we only focus on x, x equal to negative 2. If we only focus on 6, x equal to 0. But if you want the whole point, it's negative 2, 2, 0, 0. All right. Your book have a very complex way to analyze it. For example, when they talk about positive, they are talking about the y value. either positive or negative for your first derivative. And when they talk about increasing, so that's just the positive part. When they talk about increasing, they mean the graph behavior for the appline of x. And then for this part, when they talk about increasing on the next part, they are talking about the graph behavior for f of x, and then the upward and downward is the concavity. So personally, I feel it's a little bit confusing, so I just did the analysis like that on top, okay? All right, let's look at the next page. Ready? If not, you can pause the video and, write down what we did. Okay, the next part says, so this is a lot of information. Hopefully you remember from the last math class, 1324. Some of you may take 1314. You're going to need to be able to graph polynomial function. So polynomial functions has 3 restrictions. So the restriction including, first, you cannot have no fraction exponents. And second restriction is no negative exponents. And also, you should have no absolute values. And then also the graph for polynomial need to be both smooth and continuous. Okay, so what they mean by no fraction exponents, because if you have a fraction exponent such as y equal to x raised to 1/2, which means square root of x, right? And your graph is going to look like a square root, which means it's not continuous. It stops somewhere, 0, 0. All right, for this particular one. Now, negative exponents means when you have a negative exponent, you have y equal to, say, x equal to raised to -2, which is 1 over x squared, right? So your graph is going to come in pieces, maybe not exactly like that, but it will have pieces. And then when it has absolute value, absolute value, sorry about that, the graph is going to be like a V, so it's not smooth and continuous. So because it's smooth and continuous, the domain for the polynomial should be negative infinity to positive infinity, because it's like continuous, right? So some of the steps you can consider when you graph a polynomial. You can find your x and y intercepts, and then think about the end behavior and see how many turns they can have. And the new tool that we have learned from the last 2 sections is using the first derivative and the second derivative. All right, so x and y intercept. To find x intercept, what do we do? Set y equal to 0. And to find y-intercept, we're going to set x equal to 0. And the next part is end behavior. So when you do end behavior, you can think about something maybe you know, such as when y equal to x squared, and a is positive, the leading coefficient is positive, it's just regular open up parabola, right? So that's an even leading power with a positive, both sides up for the end behavior, like an open up parabola. And if you have y equal to negative x squared, which a is negative, so again, even leading power, a negative, both sides down like an open down parabola. So for this particular one that we just talked about, this is for even leading power. We can say the end behavior is either both side up or both side down, depending on the A value, right? So if A is positive, it's both side up. If A is negative, it's both side down. So that's for even leading power. All right, so hopefully you remember some of this information from the last math class. So what if I have odd leading power? What would be the end behavior? So again, I would suggest to think about something you know. You can think about y equal to x cubed or y equal to negative x cubed. So y equal to x cubed is just a regular S-curve with A is positive for this one, A is negative for this one. So odd leading power A positive, right side up, left side down. And if A is negative, it's going to flip it, right? So with odd leading power, the end behavior would be one side up and one side down, depending on the A value, right? So that's the basic end behavior, depending on the leading power is even or odd, if the leading coefficient is positive or negative. So you may have to review this a little bit if you don't remember that. The next thing is the maximum turn of the graph is going to be n minus 1, which means the leading power subtract 1. So if it's a 4-degree power, 4-degree polynomial function, then you subtract 1, you have 3 maximum turn. All right, so the next part is where is the first derivative help you to decide where the function is increasing or decreasing. And then using those, you will be able to find the local extremer. And when you do the second derivative, this is about concavity, right? So you can figure out the function is concave up or concave down. And because you have the concave up and down, you can find the inflections point. Okay, so just a little bit more information. When you have applying of x equal to positive, the function is increasing. When you have the first derivative equal to negative, then your function is decreasing. If it's equal to 0, that represents a critical point. Critical value sometimes will be related to if it's local maximum or minimum. The second derivative, if you have positive or negative. So positive look like a happy person, concave up. Negative look like a frowny face, sad person, so concave down. If you have the second derivative equal to 0, then it is inconclusive. Alright, so this kind of sums up a lot of information for this section.